What is up, everybody? Mark on the mic, my good friend Ryan Muckenhern across from me, and in front of me, my trusty printouts. Ryan, the other day, we were in your car, and you were playing one of your favorite songs. The chorus was Stop Hammer Time. And it made me think, we talk a lot about bullets on the podcast. One we haven't talked about, hammer bullets, which fall within the genre of a copper bullet, something that I know you're a fan of. But these things, they're a little different.
Yeah.
They operate, I guess, what I would consider for a all copper or homogeneous projectile.
Whoa.
Hey, if that term was confusing, let me know. Somewhat unconventionally.
Yeah.
Let's talk about these things. Actually, no, I'm going to read. This is from the website, so we're going to give a little background. I printed off the website again. Hammer bullets are custom turned on a CNC lathe using only the highest quality solid copper. So they're a copper projectile. They're not like a gilding metal, but they're not necessarily designed to stay together like we're used to.
Correct.
With, I'd say, a quotation mark, traditional copper bullet.
Correct.
They impact, they open up, and I'd say rapid expansion, instead of the petals, curling back and staying, I guess, intact with the bullet, they shear off.
Yes.
Creating multiple wound channels. Mm-hmm. And I think that's really unique.
Yeah.
There's a lot that I like about and that I've seen for me personally on big game success with bullets that are, like an all copper or a gilding metal or a bonded projectile, which I'd say all three of those maintain, even though the bonded bullets have lead in them, but all three maintain the principles of expand, stay intact, drive deep, penetrate, make two holes. This one is more rapid expansion,
fracture,
but the shank of the bullet continues forward. So kind of one of those things, a quotation mark, best of both worlds sort of thing.
Yeah.
I haven't used these. Not because I don't think it would work. I just haven't used these.
Sure. They're kind of new.
They're pretty new.
Yeah.
So even on, here at Vortex or on the interweb, you look around, and I think there's a lot of intrigue, but tough to find. At least, okay, not tough to find. You can find it.
Sure.
I feel like one thing I found a little bit of, two camps.
Yep.
I think there's people that are like, I've used these, I've had insane success with these. I don't think I'll use a different bullet again in my life. And then there's other people that are unsure. But then there's always that constituent of folks that have an opinion on the internet, but haven't used them.
No.
Yeah, it's amazing.
Yeah.
So I'm trying to, I guess weave through this myself, and I'll say, like, I've used a variety of bullets throughout my hunting career of all different manner of construction, from cup and core to bonded, all whatever, right? Core locks to interlocks to all the things.
Oh, yeah.
Right? They've all made things pretty dead.
Shot placement is key.
But then I look at this bullet design, and they have several different bullets. I've got them here. We can kind of go through some of the different attributes of their offerings. I'd say one kind of sticks out to me the most for what I think I'm into.
Is it the HHT?
Yeah.
Oh.
You know me all too
right there.
well. It is in front of us. Yeah, we should mention, if you're watching on YouTube, we have a couple of the offerings in front of us right now.
We have an HHT, which is new, I think, last year, and then the conventional Hammer Hunter.
Mm-hmm. Which is more of a very small hollow point.
Yep.
On the tip of the projectile.
Yep. Me-plat.
Yes.
Yeah.
Well, now that we're talking about the HAT, should I just
read a tagline, Mark?
I'll give you a little tagline. Well, even though I just said it, but this is from the website. It's from the horse's mouth here. And this kind of just goes into how they operate, which, again, this is a little bit redundant. But the hollow point polymer tip designs intended for big game hunting applications initiate expansion upon impact, shedding petals immediately, right? With the remainder of the bolt staying intact with a blunt front for optimal wound channel. I'm going to actually, before I get into the specific projectiles, I want to talk about this too. And we have our visual aids to illustrate it, Ryan. They've got what the PDR, parabolic drag reduction here. So the bearing surface of the bullet incorporates the patented PDR design, parabolic drag reduction, a continuous up and down curve from the shoulder to the boat tail. It reduces friction in the bore, which equates to decreased pressure and the ability to achieve higher velocities. So what they're talking about here is, I guess, these up and down grooves in the bullet. I feel like we see these types of things in other copper projectiles, which I would call a relief groove.
Sure.
Are these
different?
Are these different? Are they the same?
I think they are the same, but they are different.
Same but different?
Yep.
Would it be fair to say that the relief grooves in other copper bullets are also reducing drag?
Yeah, absolutely they are. Certainly. I think the way that Hammer went about it, I really like. So when they talk about the parabolic component to this, so if you look at, say, a Barnes TTSX or a Barnes LRX or a Hornady CX or the former GMX, your grooves have a square top. So
yes.
it's as if you just took a cutting tool and just buzzed a hole, or rather a channel, into the shank of the bullet. Whereas the hammers have this, radii that then comes up to a fairly small bearing surface on the top of each of those points. And it's most pronounced in the HHT, and then in another bullet that they have called the Absolute Hammer, which is a really interesting projectile. The HHT is not one that I've worked with, but I've worked with a fair amount of Hammer Hunters and Hammer Absolute Hammers, and really interesting projectiles. So they do, and especially on the HHT and the Absolute Hammer, they do those grooves differently than a lot of other people are doing grooves. And I think it makes a difference. And so these bullets I grabbed from our very own Travis Magnum Jones. He was loading these in his 28 nozzlers. These are the 170 and 177 grain HHT and Hunter, respectively. And we were talking about load data and his findings with these projectiles. And his previous loading for that 28 Nos was a 168 ABLR that he started running into pressure at about 3250. He's running the HHTs at 3350 with no pressure and spectacular accuracy. And so we've added a bit of mass to the projectile, 2 grains, not a huge amount, but we've added substantial length in comparison, and which is going to eat case capacity, which is going to build pressure. This is if you switch from a bonded or a cup and core design and you move to monolithics. These are things you need to be cognizant of when you're loading them. And he's had phenomenal results with them. Shooting him. I was with him when he did the original ladder test on him, and I was actually hanging out with his daughter in the observation room of the range. He ran in to shoot, and like the first 5 rounds, he stands up and he goes like this, and I'm like, good, bad? And he's like, A-okay. And so he's working through a super coarse ladder, and his load data immediately printed higher than what book would suggest, which was great. That's a bonus. It doesn't always happen. And then his aggregate, despite this coarse ladder, was like all ragged whole.
Right.
And then he again goes back and he refines his load, picks the node that he likes, and then went into it, and just phenomenal ESs, phenomenal SDs, incredible velocity, incredible accuracy. He's very pleased with them. And his findings are certainly consistent with what I've found with shooting these bullets. They're very neat. They're very neat.
I'm going to add, to this PDR talk, not a PDA, Ryan. That's different.
Yep.
The PDR design on the bearing surface has proven to be very consistent and forgiving for the hand loader. Seating depth adjustment for accuracy has been unnecessary, making for much less time spent creating an effective load. So they seem pretty forgiving in that manner.
Yeah.
Looking at there are recommendations for the seating depth too, right? But what about this is making you can kind of seat them how you want.
So that's the part of exterior ballistics, chamber design and chamber dimensions, and individual cartridges that I still categorize as voodoo because I'm not necessarily smart enough to unpack that. And everybody's got a different twist on how to approach load development. And so, for example, most of the time when I'm starting a load with a rifle, I'm finding lands and grooves and I'm subtracting 20, 25 thousandths from there. That's where I'm starting. Or I'm constrained to an internal box magazine or a detachable box magazine, and I'm 10 thou off the box. And then I'll work my load from there, right? If you look at Barnes, which I'm an unabashed fan of, most of the time they're recommending you're starting at 50 thou and then subtracting from there. I guess if I cogitate on this and I think okay, why would one bullet be more or less forgiving or more or less sensitive to C2 depth? And I suppose it would have to do with bearing surface on the bullet shank and then how it interacts with the lands and grooves, or rather the lead into the lands and grooves, and then also how it interacts with the case mouth and the case neck. And these are long bullets because they're solid copper, but they have such a minor bearing surface on the shank because of that groove geometry that I believe maybe some of that sensitivity is completely zerped. It's just gone.
Okay.
And so the bullets that I've worked with from Hammer in the 6.5, the 7, and the 30 caliber pallet are their absolute hammers and their hammer hunters. I've not worked with the tips yet. Call it time or call it laziness. I'm not sure which, but I found exactly that. So I took my Tikka 6.5 Creedmoor, which is a rifle you've used, I've used a lot. It's a known quantity in my life. And I made a slave case, made it 10 thousandths off the box magazine, max OAL using the Tikka M Plus magazine. I threw a course ladder together, 3 shots per half grain increment, and went to the range, and every one of them was like the proverbial ragged hole. I thought, oh, this is fun. So the absolute hammers are a little trickier because they don't have a conventional ogive that you can run into lands and grooves with and figure out where they are.
Right.
And they require a little bit more, I'm going to call it finesse or thought into how they're loaded, neck tension, things like this, because they're kind of technically a bore rider. And
that's what I was wondering.
Yeah.
As I'm reading about that, I'm like, okay, is that what we're dealing with here?
Yep. So their shank is a larger diameter than their ogive. And their claim to fame is up to 200 feet per second faster. And again, this is a reduction of bearing surface and then also kind of a slipperier profile. Now, I didn't hit that. I didn't see 200 feet per second more. What I did do is I went so far over book that I basically ran out of powder capacity and never encountered pressure. I never had bolt lift. I never had ejector swipe. I never had firing pin cratering. And I got more velocity. I didn't get 200 feet per second, but I got more, and I think that's because I stuffed more powder in it, more than anything. But it was interesting to not hit conventional pressure signs.
Mm-hmm.
Now, I don't have a pressure meter. I didn't have it on the gun, so I don't actually know what the peak chamber pressure was. And so buyer beware, or not buyer beware, hand loader be aware.
Mm-hmm.
But it was really interesting. And no matter where I placed those bullets in C2 depth, whether it was like Sammy COAL or whether it was me running out to the end of an M Plus magazine, which there's a lot of extra space on a 6.5 Creedmoor and a Tikka to do so, with a Sammy chamber, it didn't matter. They all just shot. And it was really interesting.
That is interesting.
Yeah. What I also love about these projectiles, prior to working here at Vortex, I worked for an OEM firearms manufacturer. We had a very upscale machine shop. I fell in love with like tight tolerances. And I think that's like interesting. I'm not a machinist. I don't know how to run them. So if you put me on your Swiss machine or your Haas or your whatever, I'm going to break it. But I like parts that are the same as they come off a machine. So I took these bullets and I think I bought a 50 pack, the first batch I bought, and I weighed them all. And they were all within like a tenth of each other. And I get it. Like, it's a lathe turn product. I'm assuming that weight variance was like tumbling media or some sort of gunk in there. I don't know. I mean, a tenth is nothing. If you take any random box of bullets and you weigh it, the delta between your low and your high can be significant. It can be grains. This was a tenth. And so they're spectacularly consistent. And the only thing that's kept me from not pushing one through something with a heartbeat is, I guess, the unknown, because they do things differently than conventional bullets do. And that's a poor excuse. Like, I really should field these. And
well, in some ways, though, like, yes and no, because we see, you shoot like a, even a bonded bullet.
Yep.
You lose some of that mass.
Yeah.
And like, we've seen it in the gel blocks that we've shot on cartridge talks here at Vortex with different bullets. You'll see bullet entered, lost the tip, expanded, some loss of material on the way, creating secondary wound channels. And then the bulk of the bullet, though, continues to move forward. I mean, same thing, different way.
Correct. And overall, like, when I audit that, like, my worst fear with a projectile moving through something with a heartbeat is core jacket separation, which I've been a part of on a multitude of occasions. And why that frightens me is because now I have potentially erratic trajectory through target. So there's often no consistency in how that jacket behaves upon impact in a non-bonded projectile. So a classic example, the largest mule deer I've ever shot, I recovered some of the jack. It was about 53 grains. An original fired weight was in the low 140s. And the path that it took through the critter was bizarre. And I've replicated that, and then I've seen that on necropsy on other animals using same or similar projectiles. And what I don't like about that is, like, I may not have the optimal attack angle on target, and like with respect to, say, broadside, right? That's optimal, right? So you just put the crosshairs where you want the bullet to go, and your expectation is trajectory through at the same angle. But when we institute a harder angle, quartering off, quartering on, etc., oftentimes you're targeting the offside of where that projectile is going, or you're shooting through structure, or you will introduce structure to the trajectory that can disrupt where that jacket goes. And if I can't reliably predict like where that's going to go, I just get nervous, right? Which is what led me to monolithics anyways, because it's any angle, anytime, for the most part. The way these work is that shank, when it breaks off and becomes, we'll just call it a wad cutter, which are renowned for tracking true, that fear is mostly alleviated.
Mm-hmm.
Yeah. The part that I don't know, and I haven't seen enough concrete evidence. I've watched a lot of gel videos, and I think they do a really good job, and Hammer's very upfront about kind of how these bullets work. But what I'd like to know, and the only way I'm going to get there is by actually shooting these at something with a heartbeat rather than just paper, is how those petals radiate after fracture. And so I don't want to categorize these as the same as some of these other projectiles that have come out that work in similar ways. The closest projectile to these that I'm aware of is a bullet out of France called GPA. That was a fracturing bullet, had a square meat plat, and was really interesting. And when they hit, those petals just kind of jettisoned out, not 90 degrees perpendicular to the shank, but at a pretty high angle away from the shank. I would be more comfortable with them if they broke off at, let's say, a 45 from the shank upon impact. Now, again, I have to shoot them at something and then take that thing apart and look at how that does. And then I have to replicate that probably like 10 times before.
Right.
Yeah.
I will say in some of the gel blocks that I looked at on the internet, I mean, even though, in the verbiage that I read earlier, it says, they expand, they, essentially shear off immediately. In the gel block, I mean, number one, the permanent wound channel looked
great.
Yep. And then when the petals really started to diverge, was pretty actually deep into the gel block.
Yep.
Somewhat to the point where I was like, well, on a broadside shot, and again, permagel is not an animal. We've said it a million times, even though we use permagel, right? It's a test medium where you can garner, some really good information,
Absolutely.
but it's not the whole story.
Yep.
But I was like, well, shoot, like really how much is this, quote, petal divergence even doing? Because it's, it's happening, you'd say like on a deer-sized animal, like if you did have that perfect broadside shot, well within the body cavity.
Sure.
So,
and I think if you can get an inch away from your shank, like center of petal to shank, and then center of petal to shank, so like net 2-inch diameter, that's devastating.
Right.
Yeah. And I think they move a little bit more than that, because as you mentioned, like permagel is interesting in how it makes bullets behave. Ordnance gel is better. Living tissue is the best. Right?
I didn't see any ordnance gel testing to look at, but
I've had a lot of folks call or email in and like ask my opinion on it. And again, I've got to be careful because I've never zapped anything with one. But I've heard their anecdotal reports. Mr. Ron Spomer, who, if I started shooting one thing a day for the rest of my natural life, I'll never catch up to Ron. He is a big fan of these projectiles. And I've talked to him at large about their performance on up to elephant. And broadside shots with 375. And he's sold. And like, that's a big testimony for me, because Ron knows what he's doing and he's done it before.
The other thing, I ask myself this question: does this, if you made an imperfect shot, maybe a little too far back, does one of those petals save your bacon?
It certainly can. It absolutely can.
I don't want to plan for a bad shot.
No, but if anybody says like, well, that never happens to me, just give it time.
Right.
I promise. Like it's a guaranteed certainty. And to your point, yeah. And like a really great case, like I had a bad shot on a whitetail a few years ago. Rick and I were hunting, I think Christmas Day. And
naturally.
Yeah. And I pulled the bad shot.
Naturally, because when I've invited you to my house for Christmas,
yeah, correct. Yep.
You don't.
I think it may have been the day after Christmas. I'm not sure. Nonetheless, we doubled up on a couple of whitetails, and my shot was kind of a crap angle. It was an unverified distance, but estimated distance, and it was like we have seconds, and took the shot, and I ended up further back than I wanted, and I hit basically the diaphragm, and ran the length of the diaphragm. If we look at the diaphragm, like perpendicular to the animal, my shot was perpendicular to the animal.
So it was a broadside, but you just kind of hit that diaphragm.
Yep.
Okay.
And it more or less just zipped the diaphragm. And so, like, I knew the animal was hit at that moment. I had decent blood, but it took off and it got into like heavy cover. And it only went maybe 60 yards. But, and like nothing that bullet touched was critically vital. It's like I didn't hit the lungs, I didn't hit the heart, I didn't hit major cardiovascular tissue, I certainly didn't hit any CNS tissue. But I zipped that diaphragm, which prevented that thing from taking in air.
Right.
And down it went. And a relatively quick recovery. Like I've had rock solid shots end up with a 60-yard jaunt.
Sure.
And so to your point, let's say you're far back and you're actually behind the diaphragm, but you have a pedal fracture and it zips the diaphragm or perforates the diaphragm or damages it in some way. Now all of a sudden that thing can't take on O2 and it's toast. And yes, so I think yes. Whereas if you had either a homogeneous bullet of conventional design or a cup and core or a bonded, and you didn't have the secondary coming out there and giving you that potential for the disruption of a critical structure like diaphragm, it's going to be a bad recovery, certainly uncomfortable.
Yeah.
And it's going to take a bit. So yes, I think that there is merit to the fracturing design, and those secondaries do have a tangible benefit for certain.
I don't know why I'm so hyper focused on these, PDRs, these little waves that are, essentially machined into the bullet.
Yep.
But I think it's of note that they're between these two projectiles, which in some ways, like I look at them, I go, well, other than the polymer tip, they're very similar, and yet they have a very different, I guess, pattern or an engraving pattern. I don't know why.
Evolution of design is one of them. So what's really cool about hammers, I've been paying attention to them now for, I'm going to say 4 or 5 years. And because they're not constrained to maybe a conventional bullet making process involving punches and dies, and they're lathe turning them, they can control their diameters, they can control their mass just with length, and they can modify their like ogive profile and ultimately like total bullet profile on a whim.
And just probably plug whatever the numbers are into the machine. And
and what's super cool is if you go to hammerbullets.com, and
I may have oversimplified.
No, kind of though, because like if you look at like conventional projectile production, the tooling is very specific with respect to punch and die style, right? To make and shape the projectile in totality. When we put this on a lathe, it does simplify it, and it does allow the maker to do a lot more things a lot quicker.
I mean, you'll see it with the machines. Some of the machines we have here, Vortex.
Yeah,
you plug whatever in, and we make micro screws that you could barely even, whatever, and then you plug something else in, and it's spitting out a whole different thing. Yeah. All the same stuff, though.
Yep. But what I love about their nimbleness is if you go on their website and you look at their caliber offerings, it's every caliber. Like, pick a diameter that's been produced in a British Safari rifle, in a archaic centerfire of some kind, and they have them. And then they're
well, that's not some giant process to spin something super boutique up.
Yeah. And what I really also appreciate is they are a boutique bullet. And by that, I mean, it's a custom projectile. And they don't treat it like that for the end consumer. Like, they're a premium projectile, but they're not spectacularly expensive.
Okay, I see what you're saying.
Yeah. So and they're really forward about sample packs, which is cool. So like typically, if you're not a hand loader and you're like, I want to try that bullet, you're committed to a quantity generally of a minimum of 50. And if you find that your gun's intolerant to it, well, then you've got 42 bullets left, or however many, that you're not likely to utilize.
Throw them in the apocalypse pile.
Correct. And with hammer, you can get them in sample packs, and you can add sample pack after sample pack after sample pack, and you can figure out what you like, what your gun likes, or meet your objective on the loading bench without having to commit to a large quantity of bullets that may go to waste. And back on these grooves, like I've seen their profiles change over time as they test, as they gather feedback from their user base. They really do pay attention to like what's working and what's not, and modify things to better suit the customer very rapidly. And I think simply because they can, and they are set up to do so. And the end result is like you have this evolution of Hammer Hunter and then Hammer Hunter Tipped. You see this PDR change visible like very quickly. And it seems to be working, which is really cool. Really cool. The tipping part too, that's a neat deal. To keep costs down on projectiles, when they send you the HHTs, they're sending a small anvil that you will actually tip the bullet with. And it's a very easy process. I don't want to make that sound
I saw that.
Yeah. And honestly, I think it was a good move. Like if you're the hand loader, you're working with the tools anyways, like it takes a second to put the tip in and you're not having to pay for that up front. You just got a little bit of time at the end. Big deal. You get to handle your bullets and become very intimate with them pretty quickly. And I think that's a cool deal.
Okay. One more thing on the PDRs.
Yeah.
And I promised to quit. But I look at it and I go, okay, cool. Less drag in the barrel, they say. But you are increasing surface area. Overall surface area of the projectile, yes.
Yep.
So are you encountering more drag as it passes through the air? Like, are you gaining on the front end, losing on the back end?
A little bit, yep.
I would have to assume to a degree, but maybe it's not, I don't know what the proportion of that is.
Yeah, and again, that's a level of physics that I can't read. But if you think about like air flowing over the bullet, and you think about like a square notch that's cut in it, you're going to have turbulence with that square notch, more so than you would with a radius notch.
Sure.
Or not even a notch, but a groove.
I mean, like I was thinking about these earlier when we were talking about those notches. You think of like a, like how a semi,
pushes air.
Pushes air.
What I was thinking,
and how like a sports car pushes air, right? And sports cars, they're very flowy,
yep.
Right?
What I was thinking of right before you said that is there's that great 3D model of a Jeep Wrangler versus a cow in a wind tunnel. And the cow is more aerodynamic. And so like you watch the facets and the angle of the Jeep create pressure and turbulence with the wind simulation put on, and the cow, the wind just flows nicely over. And yeah, correct. So that huge thing, absolutely. So to answer your question, to the best of my ability or recognition of it, is when you look at that radiused cut, it is more aerodynamically efficient than a notched square cut. So you do have a concession in that maybe your drag model isn't as spicy as one that has no cuts and has a very short shank and very small bearing surface and an extremely long pointy ogive. Think Berger, VLD, Nosler, RDF, etc. But you are maximizing the capability of a bullet that requires this kind of length,
right? By
mitigating shank contact with the bore, i.e., bearing surface, and then giving it that smooth transition between each groove.
Sounds like these guys are, when it comes to twist rate, proponent of more is better than less.
Faster is better. Yep.
Yeah.
Yep.
Yep. They only list their BCs and G7s.
Yep. Which is actually correct.
Right.
Right. So we talk about that a lot, G1 BCs, even up until not that long ago.
I mean, we did a podcast on it, G1 versus G7,
I can remember picking up some of the first Hornady AMAXs in 6.5 Creedmoor, a 140 AMAX. It was a G1 BC posting. That's a G7 profile bullet. And like, that was just how the industry did things. And it wasn't, we'll call it 2012, 13, 14 maybe, where people really started, or I saw anyways, people really started putting focus on correct model for the projectile. And so a bullet like this, long ogive, bow tail, G7.
Right.
That's correct. Yeah.
I mean, it's correct. It's more accurate for this style of bullet. But still, when I look at a G1 versus a G7, like I feel like I'm like, well, regardless, like more is better. So
yeah. Yep.
I don't know. But I think that is notable, and it does make sense. Should we go into some of these specific bullet offerings that they have? We already did a little bit. It says the Hammer HHT is proven to be their most effective hunting bullet yet.
So HHTs, Hammer Hunter Tipped.
Hammer Hunter Tipped,
so
yep.
If you're watching again on YouTube, bullet that I'm pointing at here, this is the Hammer Hunter. So it has, I'm going to call it their older groove styling, no tip present, large me-plat on it. HHT, new groove styling, and now the black poly tip.
You've got the stone hammer.
Yep.
It's our line of bullets that designed for normal range hunting, where BC is inconsequential, so for most cartridges, 400 yards or less.
And what they're doing with the stone hammers is they're giving it a giant me-plat.
Right.
And they're maximizing that just brute force impact, right? So we give it this very big me-plat. Again, what they say I think is very important to the hunter. It's very easy to get transfixed or mystified or drunk on the thought that if you're going to hunt whitetails in Wisconsin, you have to have a bullet with a G7 profile that's approaching the 3s for your 250-yard shot. And the reality is, no, you do not, right? Like it is.
I still won't.
I know. It is inconsequential though, right? And so here they're taking a bullet design and they're maximizing the terminal performance package at those 400 and in distances, where the BC does not really come that big into the equation.
It says approximately 80% weight retention. And then, like you said, has a larger hollow point for just
hammering,
getting with it.
Yep, getting with it.
Hammer Hunter, I mean, that's pretty darn similar to the stone hammer.
A little more spicy drag model.
Mm-hmm, mm-hmm.
Yep.
And then, like you talked about, the absolute hammer, it says similar to the Hammer Hunter. Bolts with the same 1.5 millimeter hollow point and the same basic form. Designed it so it cannot be engraved on the ogive of the bullet.
Yep.
And then they kind of reiterate what you said earlier. Because of the very low drag engraving pressure, the absolute hammer of the absolute hammer do not. Hold on, practice my words here.
Mm-hmm.
I was trying to paraphrase it as I read it, and then now I'm just going to read it. Because of the very low engraving pressure, the absolute hammer do not line up well with conventional bullet loading data. They should only be loaded by expert reloaders that are capable of working up a load without any supporting data. Kind of a mystery box there.
And that's changing too. So their load data has gotten well populated. So here again, if you go on to I think it's called the Hammer Time forum, where you can find load data.
Okay.
That is either created by Hammer or sourced from a select group of very proficient hand loaders. They get into the AH or absolute hammer load data pretty well.
Mm-hmm.
And they're giving you great guidelines to start with. The only thing that I noticed different with mine is I monkeyed with neck tension, and I hate bushing dies. And so I ended up using Lee Factory crimp dies, which are extremely inexpensive. And the way that they crimp, like generally I have no time for crimping on bottleneck rifle cartridges. It just drives me nuts, and it's very difficult to maintain consistency with. But the Lee Factory crimp, call it type die that closes around the neck very consistently. And rather than exert force simply on the case mouth, it's kind of pinching the whole neck in a way. And so I used the Lee Factory crimp and just the lightest kiss of crimp on the neck. And I would say I saw a result. I wouldn't say that it was required. It wasn't detrimental. It worked.
Mm-hmm.
So yeah, they're a little different to work with. Nonetheless, like the workup was not, when I first read that statement, I was like, oh boy, what am I getting myself into here?
Well, and like you said,
yeah.
Some of that information is improving over time.
Oh, big time. Yeah. And so, at that point, it was like, well, let's see what happens. I don't think I'm going to blow up small powder charges. And I didn't. Like, it was fine. Overall, I preferred the Hammer Hunters just because that part of my brain was turned off. I just load them like a regular projectile would be normally. I did appreciate the fact that they seemed to be completely insensitive to COL variants, which was cool. And I could use the case, as much of it as I could relative to my magazine. And saw the same thing in 280 Ackley as well. using the app or the Hammer Hunters. Yeah, so cool bullet, big weight ranges too. So in coppers, as I've said before, I'm generally one to scale down in weight.
Sure.
So that I can go up in velocity and defeat guaranteed deficiency in BC. So, like, if you look at a lead core bullet of the same length and relative profile, it's going to have a significantly higher BC. That's
right.
That's just how that works. If I can go, we'll just use the 308 as a really good example that I have. 130 grain TTSX is out of mine. I can push those at 3150 out of my Kimber. And honestly, they scald my slipperiest 6.5 Creedmoors to like 400 or 450 yards.
Sure.
And that's just velocity. That's doing that.
Right.
You can do the same thing with hammers too. You can get light for caliber conventional, light for caliber bullets and do really great things with them. So you have an option from them actually in all of their lines: Absolute Hammer, Hammer Hunter, Stone Hammer, Shock Hammer, which I think may have gone away, and then HHT. That, like Travis here has the 170, 177 respectively. I mean, it's a heavy 7, and especially in a copper. But you can go down. If you just want an absolute laser beam, they have an option.
Right. A question I would have, though, in regards to that, and again, how this bullet, a lighter version of this bullet would operate compared to, you know, a similar, like, weight in the barns for a respective caliber, is one thing that you are banking on with a bullet like that Barnes is it's not going to shed that mass along the way, right?
Yeah, but again, when we look at,
so like you're kind of getting,
it's hard with solids because you don't have to worry about that core jacket separation creating a very erratic and unpredictable shape of your jacket and your core. So, like, hammers are designed to fracture.
Right.
What we get is this blunt wad cutter shape, which is predictable and which inspires confidence for me. If I drive a Barnes to the point of pedal shearing, I still end up with a very predictable shape.
Sure.
And the loss of mass somewhat is counterintuitive to the design. Like maybe you pick up a homogeneous projectile because you want as much weight retention as possible. Relative to any bimetal bullet, you will always have the most weight available, even with shearing. So like I drive, pick high BC polymer tipped bimetal design projectile at warp speed, and I encounter a scapula or I encounter a humerus or whatever. That thing's turned into sand. And then you have to like weigh all the pieces. Whereas even with a hammer or even with the Barnes, and we shear pedals, you're still ending up with I think a net higher weight of mass of the majority of the projectile going through it.
I think on the low end here, at least what I'm seeing here, and like on this Hammer Hunter, you're looking at 60 to 70%, which I guess is still
high,
pretty darn good.
Yep. And 60 to 70% of a controlled and predictable shape and diameter.
Sure.
Which translates to straight
line tracking.
Yeah.
Yeah. They also offer a target hammer, non-expanding.
Yep.
But I could see, because of the consistency and precision that they can do with their, since these are essentially a turned bullet, a person might appreciate that.
Oh yeah. Yep. Having a target analog to your hunting analog, you will appreciate a higher BC. In my limited scope of testing, like absolutely backflips over the accuracy that I've got out of them. Like if it fit your budget and this is what you wanted to use as a match bullet, have at. Like I don't think you're up a creek.
Right.
Yeah.
Like you said, if it fits your budget.
Yeah.
Because man, I've used some, different target bullets over the years, and I'm also probably not as picky as some folks, but man, those things are doing a pretty darn good job.
Oh yeah.
All tested down to 1,800 feet per second, which I think is, that's a solid terminal window there.
Oh yeah.
For velocity.
If you think that's high too, audit some of your cup and core projectiles. A lot of them are in the same range.
Sure.
And that's to at least get to some sort of usable expanded diameter. Whereas these, that comes from, okay, we're gonna deploy at minimum, if not fracture. So, and that, folks, is the thing that we should all pay attention to with projectile selection, is its minimum velocity threshold for function.
It's the thing, outside of, just overall construction, BC, like all the things. But when I'm looking at, for me, that is the determining factor when I say I will shoot at a game animal this far or I won't. Well, outside of, environmentals and things like that.
Yeah.
But just for sheer, looking at the data sheet,
Yep.
if you will.
Yeah, you take into consideration that you can hit the target first and foremost, but then also that, to your point, like the thing that is at the top of my requirement list is, does the bullet function?
It doesn't matter if it has enough energy, or at least to me. Now, oftentimes it does,
Yep.
at least for my, my predetermined things that I like to see, right? Because I'm looking at the velocity threshold for the bolt to function. And usually those things go hand in hand. But
Yes.
there you have it.
We hammered it, Mark.
You took the words right out of my mouth. You stole from me.
Great song by Meatloaf.
You hammered it? That's
No,
the song?
took the words right out of my mouth.
Oh. Meatloaf, huh? Boy, that's a meal that I do not think it gets the credit that it deserves.
Yeah.
There's a lot of people that don't like it.
They never had a good one.
I would say the same thing. All right. There you have it, everybody. Questions for you guys out there. Like we said, this is relatively new projectile company doing some pretty neat stuff. Have you been using them? What have you been seeing as far as success? Have you been curious about them, been researching them yourself? Mostly I want to know, have you shot some critters with them?
Should I shoot some critters with them?
Should Ryan shoot some critters with them?
We were just talking about this yesterday, Mark. We have such an opportunity for ballistics testing, terminal ballistics testing with whitetail does.
Yeah.
We ought to.
And then, yet again, last year, guilty as charged. I didn't shoot one.
I did.
I shot a little buck, though.
Yeah.
So, I don't know. We say it every year.
Let's do it this year for real.
We mean it this time?
Yeah.
All right, everybody. Thank you for listening. Like I said, please comment if you've been using these. I'm curious. We want to hear. And we mean it this time, I guess. So, we're going to go shoot a few more whitetail does this year. All right. Take care.
10.
Happy hunting and shooting. That's a bold number. We'll catch you on the next one.
See ya.
Bye.